This is an example of a piecewise defined function. And what we're doing is looking at how two different functions, here we've got f of x, which is not defined at -2, but we can see it's approaching the value 4 at -2. At -1, f of x is equal to 3. At 0, f of x is equal to 2. You see that we're going to go horizontally to get the plug-in value, vertically to get the output value. So at 1, f of x is equal to 1. At 2. At 3, f of x is equal to 1. At 4, f of x is equal to 0. And at 5, f of x is equal to -1. G of x is the blue line. It's actually defined all the way back to -4. So at x equals -4, g of x is equal to -5. Let's see what our next whole number value. At x equals -2, g of x is -4. At x equals 0, g of x is -3, and it stays -3 until we have x equal to 4, and it looks like g of x is maybe -1.5, and then finally, although g of x is not defined when x equals 5, we can see that it gets very close to the value 0. So what we want to do is find these values. So the first thing we want to do is look at f plus g evaluated when x is 1. So what I'm going to do is here x is 1, and I can see f of 1, that's 2. G, let's get a different color. G of 1, well, that's -3. So f plus g of 1, that's going to be 2 plus -3. So we get -1. For g minus f at 4, first thing we want to do is find g at 4 and f at 4. So here we are. Let's do g of x first. At 4, g of x, we said that that was about -1.5. F of x, when x is equal to 4, is 0. So we've got f of 4 equals 0. So we've got this g minus f at 4. That's the same as g evaluated at 4 minus f evaluated at 4. Well, g evaluated at 4, we said that was -1.5. F evaluated at 4, we said that was 0. So we get -1.5. The next two are going to multiply. So let's write out this first one. G times f evaluated at 2, that's the same as g of 2 times f of 2. So we need to find those two values. We're going to multiply them and get the answer. Let's go back to the graph. At 2, you can see that f of 2 is the same as f of 1. It's 2. And at 2, how funny, g is also the same as it was at 1. So g of 2 is still negative 3. So this product is going to be negative 3 times 2, which is negative 6. The next one, we're evaluating f times g at 3. That's the same as f of 3 times g of 3. So those are the two values we need to find. Go back to the graph. I can see that at x equals 3, g is still equal to negative 3. So let's just write that down. G evaluated at x equals 3 is still equal to negative 3. For f of x, when x is equal to 3, f of x is equal to 1. So I can write that as f of 3 equals 1. And now I've got the two values to plug in here. So we said f of 3 was 1. G of 3 was negative 3. We get negative 3 for the product. This quotient is just exactly what you would think it'd be. G evaluated at negative 1 divided by f evaluated at negative 1. So those are the two values we want to find. Let's go on the graph. We've got x equals negative 1. I'm going to go vertically up to f of x. I can see that f of, when x is negative 1, f is equal to 3. And for g of x, I'm going to start also at negative 1. When x is equal to negative 1, g of x is negative, I'm going to call that 3.5. Okay, so then we get the values. We've got negative 3.5 for g of negative 1. F of negative 1 is 3. And I'm going to make that look better. So let's see, 3.5. 3.5, that's the same as 3 1/2. And I want to change this to an improper fraction, to a regular pure fraction. So 2 times 3 is 6, plus 1 is 7. So 3.5 is the same as 7/2. That means negative 3.5 is the same as negative 7/2. So I've got negative 7/2 times 1/3. And I could have written that, let's go ahead and do that. I could have written that as negative 7/2 divided by 3. Well, 3 is the same as 3 over 1. Keep, change, flip. Negative 7/2 times 1/3. What I did here was just leave this 3 in the denominator and move it over. But you can see we get the same thing. Now I'm going to multiply across. The negative stays. 7 times 1 is 7. 2 times 3 is 6. So the answer is negative 7 over 6. Although with this kind of thing, this answer, negative 3.5 over 3, would be fine also. All right, the next three are the more enjoyable ones because we're going to do an input into one function, look for that output, and plug it back into the other function. So we're going to start when x is 1. So let's start with a clean graph. Here is x equals 1. And we want to find f of 1. Let's move this up. We want to find the inside part, f of 1. So f is going up. f of 1 is equal to 2. This notation means I want to plug the answer, f of 1 equals 2, into g. So I want to find g of 2. So I want to let x equal 2 and come to g, and I see that I get negative 3. So the answer of g of f of 1 is negative 3. This next one, we're going to start with x equals 4. Here's x equals 4. And we start inside out, so we're going to plug 4 into g. And let's see, that means we're going to evaluate g first. And we get g of 4 is negative 1.5. Now we're going to find f evaluated at negative 1.5. So we're going to take the answer for the inside part and plug it into the outside part. Let's see, negative 1.5. Here's negative 1.5 on the x-axis. And we're going to go to f of x, because that's what this f indicates. And it looks like we get 3.5. Finally, we're going to find g of f of 5. So we're going to start with x equals 5. Here's x equals 5. And we want to evaluate f first, because f is inside. So that means we're going to look at the red graph. At x equals 5, f of 5 is negative 1. So we've got f of 5 equals negative 1. That's the value we're going to plug into g. So we want to find g of negative 1. So we're going to go on the x-axis, negative 1, go down to g, and we get negative 3.5. I hope this helps a little bit. So, keep asking questions. It helps. Thanks. Bye.